Okay, hopefully it's recording. And hey, everyone tired? Wanna stretch a little bit? Had some 5 minutes break. Thanks so much for the sponsors and for Bill for inviting. And I'm trying to bring something different here, apart from what we used to have: logic apps, Azure functions, API management, deployment. And anyone here work with containers? Docker containers, Kubernetes, who never did like a Docker run before, never wrote a Docker run on a command line, never. No, come on, I know there's many people that did. Okay. That's maybe for you, but I'm going to try to bring some entry-level discussion pretty quick, just for you guys to catch up. But the idea is like, how are we going to integrate the new generation of service using Kubernetes like AKS to the Azure service itself. We don't have like two solutions, different tools to manage these things. We have just one thing that we can manage. That's what we call Open Service Broker API. That's not a new thing. That's one thing came from Cloud Foundry, and you're going to see that. And you guys probably, most of you know me already, and I'm working for MBA now as a DevOps guy. Not that kind of DevOps that Simon was talking about here, like a different generation of DevOps that looks more for containers, and is a different word. And you guys are going to see that's completely different. He knows probably that. That's changing a lot of things that we used to do. And it's happening for some companies, but the way that we used to do is still valid. It will be there for many, many years. But there is another way now to deploy, to build things, and to do pipelines, and doesn't mean that the other way is wrong. It's just a different way. And I have developed background. I used to do a lot of talks about API management. You guys want to ask about something about API management, I'm happy to answer as well. And but that's what I'm doing at the moment. And the agenda is that Open Service Broker, going to see what's that, AKS, the Kubernetes service, a quick introduction, see how that works, and how the Open Service Broker API integrates with that. You're going to see that. And I have something here fresh from Redmond. We just come back, Bill and myself and the MVPs from the MVP Summit. We had a lot of NDAs. I can't say anything about the NDAs, but I can say about Visual Studio Connected environments. And I just got authorization from the team to show that. It's a private preview. Means that anyone here can sign up for the private preview. I'm going to show the link. There's a link at the end. You can sign up yourself. And it's very, very interesting for developers. Who is a developer here? Yeah, you'll be happy with that. If you start to work with containers, you'll be very happy. And it's going to change a lot of Simon would say. And it's a game changer, really. And it's not going to be done. I don't know how VSTS is going to follow that. There's a new version of Jenkins just to do that. They call Jenkins X. Was released 3 days ago, like a proposal, and done by by Cloudbase and the same people that did Jenkins. They call Jenkins X. And VSTS, I know there are a lot of things happening, and but let's see how this works. Just see. Yep. Open Service Broker was created by these platforms like Kubernetes, by Service Fabric things that want to integrate with like service providers, SaaS providers or ISVs, and they want to have like some kind of a broker API that everyone can talk, and we can request service like a marketplace, that's why we're going to see they call that service catalog, exactly because it's like a marketplace, okay, and they just starting creating these a few years ago for Cloud Foundry. That's a private way to create clusters, and it's used a lot and still growing a lot. And Cloud Foundry created that, And when the containers guys, had to look on these, like the AKS team, and before even be like Microsoft, was a company called Days that was acquired by Microsoft like a year ago. And they start work with Red Hat, Pivotal, and Google itself, Cloud Foundry, to create this broker that everyone can talk. And then when I have my application, I want to talk with some kind of service from one provider. It's not just Microsoft, Azure, or any provider, any SaaS provider, we can talk this. If they can talk this broker API, we can request a service from them. And what's that integration with AKS? Everybody knows that the container now in Kubernetes is the buzzword. It's not a buzzword anymore, it's reality. I'm working on NBN just doing containers with Kubernetes. We have a few projects using Kubernetes. A few of those projects are using on-premise, some on public clouds. And how are we going to follow these things? We don't want to manage these clusters and have to manage maybe YAML templates or different things. We want to talk natively from my platform to the service, to Azure service, okay? And what they call Open Service Broker API for Azure is just an implementation of this API, of this broker API for Azure. Very simple thing. That can be used by many services. On Azure, this Azure implementation works for Cloud Foundry. They can talk natively with Azure and ask like a database on Azure. The beginning of this thing was more like, okay, I can deploy anything on my private cluster, like Kubernetes. Okay, it could be on-premise, I can deploy, but I don't want to manage database. I don't want it. I want to manage stateless things, but I don't want to manage stateful applications like database, storage and many other things. And they said, okay, we have to integrate our platform with those services. Then we can get a MySQL from Azure, we can get a SQL Server from Azure, any other service that service already providing that. But let's say that I want to install WordPress, we're going to see the demo here. I don't want to manage the database. Okay, the application is easy to install, it's just like a stateless web server, maybe an API, but the database is MySQL. And Azure provides a high availability MySQL, CosmoDB, all those services. And then Microsoft create the broker API for Azure. And the broker API is very simple. You have like four ideas, concepts, is like catalog, service instance, and bindings. What do you mean? My application, my cluster, let's say Kubernetes, want to talk with, or your application want to talk with Azure. They can, the first thing they have to know where the catalog is, where the Azure broker is. Okay, that's what we call the catalog. And then you, from that broker, from that API broker, you just give me all the service that you have. You ask Azure, give me all the service that you have. You're going to say, I have MySQL with that plan is free, this one I have to charge. You get like Azure portal in an API with all the information that you need to buy a service, like a marketplace. When you're happy with that information, you just say, I want to create an instance of this service. Let's say MySQL with like a free plan. And you're going to call with your subscription, you're going to call Azure, but all integrated using a common API that everyone talks. You don't have to know how Azure works, how Azure API works now. The only thing you have to know is how Open Service Broker API works. And then you can request that service. And once you have this service here, doesn't mean that nobody's using. And that's the last piece, that's binding. Now I'm going to say, okay, that MySQL that I created called, test1, be used by my test1 application. Then I bind them together. And in containers, there is one thing very important, that's injection of secrets. And with Kubernetes, what happens is we can get the MySQL with the password and and inject that inside the container that's running in your cluster without even you know the password. Okay? You don't have to know the password. Because one of the main problems of the password and secret management is, are you going to send an email for the guy with the password? You open a ticket with the help desk, they create a MySQL on Azure, and how they send your password? Anyone here? By email? Have you got the password by email from service desk or from help desk? Come on. Nobody never got? Have you got a password by email from someone before? Yeah. Then that's very serious thing, and this thing can help with these things. It's all automated. When we talk about DevOps, we talk about automation. We want to be everything automated. We don't want to have to open a ticket with 1 week for operation team to create a MySQL on Azure and send you back the password by email and the connection string or something. You don't have to. This will be all created. The only thing I'm going to say for my class is I want to create WordPress with SQL Server on Azure, with my deployment scripts that you're going to see with technology we're using these days. And for just to, for you guys to catch up, if you never saw containers before, I'm going to do 5 minutes introduction what container is. The first thing, container is not a VM. Container is not virtualization, Hyper-V, or whatever you want to call. Container is just a process. It's a process isolation. Okay, if you want to, in 5 minutes, if you want to understand what container is, and Kubernetes is just the orchestrator, is someone orchestrating the containers, the process. Okay, and Docker is pretty much the guy that creates the process, and Kubernetes is the guy that is taking care of the process to make sure that they are all running, they are all fine, and lots of other things. But let's see if I have another one. If you want in 5 minutes understand what container is, just watch this guy. Container was nothing. Docker was nothing 5 years ago. Okay, this guy, Solomon Hutz, he went to a Python conference, and they gave 5 minutes lightning talk for him. 5 minutes. If someone offers 5 minutes talk to you, have a good idea, never say no. Go there and say something. And he got these 5 minutes. That's the feature of Linux containers. 2013, exactly. Yeah, 5 years ago, and he showed for the word Docker. That was a project that his company, .cloud, was creating to automate, for DevOps automation, to deploy websites. They started creating containers, and because they deployed many websites dynamically, they said, wow, we need to automate these. And they saw on Linux, they have Linux containers. They call LXC. They used to call Linux containers. It was just like a process isolation. C groups, LXC, and they create this CLI tool called Docker. That you could say Docker run and create a process isolated on Linux that nobody could, be completely isolated inside your operating system. And that was Docker. Just watch it. 5 minutes. He changed the word in 5 minutes. Okay, because you're going to see the next year will be everything be container. If you guys don't know, Docker Cloud is 100% containers. Even if you create a VM on Docker Cloud, on Google Cloud, is a container, operating this VM itself. Then, if I stop here for a second and go for, just before I go for AKS, and that's what I call Docker. You come here, install Docker for Windows, okay? And you have this whale here at the bottom. Docker is running. See Docker here, Docker for Windows. And there's a lot of configurations here. I'm running at the moment Windows Linux containers. You just open your PowerShell, and you do Docker image. I have templates here. It's not like a VM. It's not anything. It's just kind of, they call Docker image, is a overlay of file systems. Because a container, there is no kernel. The container doesn't know how to talk with hardware. There's no kernel. It's just the dependence of your application. What containers is, they get like, create one process with all the dependence that you need to run your application. Let's say .NET Core, the runtime. If that's the only dependence that you have to run your application, that's the only thing that you need inside the container. You don't need the kernel. You just need some package to run your application, okay? And you can create a container from scratch, and you just install the package on Linux that you want to run your application. You can do that. That's one way to do it. Along the years, people started creating what they call templates or images, so base image that you can start from there. You don't have to start from scratch, and you just say, I need ESP.NET Core to run. And they will get all the dependencies from ESP.NET Core that I need to run my application and run one container. Then, not sure if I have here. Say Nginx. Nginx is a web server like IS. You can just say, if I do Docker PS, I can see the containers that I have running here. See, I have two Nginx. Can you guys see that? And I can create a container. I can go inside the container if I want, and you have to do -it. That's it. I'm inside the container now. If I do clear, that's a Linux container. I just execute a bash shell inside the container. I said for Docker, can you run bash inside this Linux container that's running? Then I connect inside the container. I just create another process inside the container that was already running, like another application that was the bash, that's a command line tool. And then I have access to the container, then I can do ls as my container. Container is nothing more than a process isolation. And I'm not going details for Windows, but after that first talk 5 years ago, I think 3 years ago, Microsoft started talking with Docker, and they create what we call now Windows containers. Okay, that's the same abstraction on top of the Windows kernel. And you can do the same thing. You can do most of the things. I'm not going to detail. There are a lot of details. There is on my slide share, there's a talk that I did 3 weeks ago. Who was on the talk? I think a few people watched this talk about Windows containers, or I call not Windows containers, containers on Windows. Because containers on Windows now is more than just Windows containers. It's Linux containers as well. Okay, and the guy showed this in 5 minutes. You can watch that and see that's amazing. And if you go back for our presentation, you're going to see on top of the Docker thing in this container. A guy that worked for Microsoft now called Brendan Burns used to work for Google. He just went for a Docker meetup like us in November, I think 2013, and he said, wow, that's amazing, but Google is doing some other things for orchestrate the containers, and let's create an open source project that we can use the same ideas that we have at Google and just open this for the community and create Kubernetes. And Kubernetes started growing, and like 6 months ago, 8 months ago, kind of become the standard for container orchestrator. I used to have Docker Swarm or other things, ECOS, but now Kubernetes is pretty much used by all the big players. Google, Amazon, Microsoft, IBM, Oracle, all of these companies are developing something on top of Kubernetes. Okay? And what's Kubernetes? It's just a cluster. It's pretty much you get these nodes that you see on the right side in orange there, what they call agent VMs, and that's all automated. You don't have to create them. Okay, you go in a few CLI commands or like the Azure portal, and you can create this cluster. Microsoft create this cluster, and it used to be like that, and now it's like that. You don't manage the masters anymore. The only thing that you're going to manage in some stage will be fully managed by Microsoft. It's already managed, like they're going to update the VMs for that. If you think about like app service that you guys are used to, app service is the same thing. When you create an app service plan and you say I want a 5 instance of app service plan, you have 5 VMs. You just don't see it. But there are 5 VMs there with IIS, with the versions of they supporting like Java, .NET, all the dependencies. But because it's a VM, all the dependencies are there. And Microsoft keep updating those, Like, do you think .NET 3.5 is still available on app service? I don't think it's not anymore. Because they keep updating. It's just going forward. And it's the same thing here. You have a cluster. In some stage, you're not going to manage this at all. And you install this Kubernetes on top to manage this cluster. And Kubernetes itself is using Docker as the guy that created the containers to create the containers for him. That's what's called Docker Engine. Okay, Docker, there is the Docker CLI, that's the command line tool. And there's Docker Engine, that's pretty much who's doing the job. But what happened, like I think a couple of years ago, a little bit less, Docker open source the main components for containers. We call containerd, run C. Means that we don't really need Docker itself to run containers anymore. Okay, and there are a few people not using as used to be at the beginning. When Docker, 5 years ago, the guy went there, he wasn't using Docker. He was using Linux containers, the native from the operating system. He just created like a tool on top of this. And now that he open sourced all the code that was used by pretty much to do the main job, that's what we call Docker CE or Moby project. That's the open source side of Docker. Anyone have access? And some components not even managed by Docker anymore. It's managed by a foundation called Cloud Native Computer Foundation, CNCF. So cncf.org, you're going to see all the projects that are managed by this foundation. And then that's what is like containers is. If you go inside the VMs, you're going to see that. Inside the VMs, you're going to see on the left side is the master. You can have multiple masters that with AKS you don't manage anymore, you don't care anymore. The only thing you have access is that load balancer here on top. You stop load balance to connect the proxy and have access to the master, to manage the master. That's the only thing now with AKS that you have access. The right side, you have 2 nodes. You can have like as many nodes you can. I think there's a limit at the moment. Not sure if 50 because in public preview. And you can integrate that with Azure Virtual Network. Okay. If you think about app service, the only way to do that the same way is using app service environments. The only way to have like an app service running inside a VNet is app service environment. That costs $1,500 per month, 1 instance, I think. Depends on the size of the instance. That could cost $700. Depends on how much you're going to pay. You not create this to have 2 nodes. If you have app service environment with 2 nodes, it'll be more than $2,000 a month.
You don't have the upgrade to the premium, but I have to teach you.
That's the premium. That's the premium. App service environments, that's the app service premium.
So it's not an AC, you can just get an app service at the higher level and all that you integrated with VNet.
Not yet. Maybe you are doing anything, but yeah, not yet. It's not the same way because that's running inside, it's like a VM running inside your VNet. And you can manage the way that you want. And all the load balance, like say you want to deploy my web app, I have a web app, an API, I deploy inside the cluster. Very simple, like script, It's all automated. You deploy there, automatically we create a load balance on Azure. You don't have to do that yourself anymore. Okay, that's what AKS. That's not using the broker API. Okay, that's a really strong integration with Azure, and that's how it works. If you want to create a cluster, I have a cluster created already, but you guys are going to have access to the slides. And if you go for the AKS web page on Microsoft website, it's all there. Maybe I'm doing a different way here. The only thing I'm doing extra, I'm telling you how to create the connector for ACI. ACI is like serverless for containers. I want to run this container, I just want to pay by CPU and the memory and how long that container is going to be running. That's what we call ACI, Azure Container Instance. They're going to, like app service with containers that we have, but this one just pay for memory and CPU and how long it's going to be running. To create a cluster, just like a few Azure CLI commands, or go on the Azure portal. And with these like 2 commands on the top here, you have a cluster.
Sorry, so ACI you pay even though it's idle or only when it's running?
Just when it's running.
So if it's idle, you don't pay that?
There is no idle. When you stop, you just stop running. Right back. There is no idle. Maybe there is no the same warm up, the same things that Azure Functions has. But let's see how this, goes forward. Still, I think in public preview, it's not like available yet, but you can do Windows containers and you can do Linux containers. And you can expose as well public. You can get IP number for these. They don't do, I think, DNS. You have to do DNS yourself, but it's a low level thing. And if you go on this walkthrough, you can see the whole thing. But the main thing is you create the resource group, create the container, get the credentials, and just use this kubectl or kubectl. Is a CLI tool for Kubernetes that you manage the cluster. Everything's done using this kubectl command line that you can install here as well. There is a command to install if you want. You can do AKS install CLI. They can install the CLI for you as well. The Azure CLI can install as well. And then you can browse. Once you browse, you're going to see the dashboard that I'm going to show you now. And you can upgrade the cluster for different versions of the product. You can scale. I want 5 nodes. Just go here on that C2 here. Scale. And every time that you scale, you can put more nodes on your cluster. There is no outscaling at the moment. It will be there maybe mid of the year, will be outscaling. That means that they're going to create VMs and destroy VMs the same way that app service is doing. Be fully outscale. Then every day is getting closer to like something like app service. Okay, and I'm going to show you something here that you guys are going to see that's very close. And that's the ACI thing that Paco was asking. That's how they implement the ACI. What they do, they just create a fake node in your cluster, and the fake node is ACI. Okay, Kubernetes thinks that's talk with a real like VM, but he's talk with a serverless thing on Azure. That's what they call virtual Kubelet, and that's how they do it. And I have on my cluster here one installed for Linux, another for Windows. Then it's like I have a Linux and a Windows node on my cluster. I have now a hybrid cluster. Okay, I have a hybrid cluster. And then I think Azure is probably the only one doing that. There is Hyper. Hyper is another company doing serverless, container with serverless. And that virtual Kubelet now is available for Hyper and for ACI. Hyper is a company with H, Hyper. And that's how it works. That's the pipeline that Simon was talking about with VSTS or something. That's the pipeline for containers. Okay, the normal pipeline is you have your Git repo there here in blue. We get the source control and you do a Docker build. You know that Docker CLI that I was showing? You have a command to build that image. Okay, I'm building my template with my dependence. The nice thing of build is once you package your application, you can run .NET 2, 3, 4, 5, 6, 7, how many versions on the same machine, all together. Because the process isolations and all dependencies are packaged inside the container. Okay, you just can run all in parallel. You cannot do that with full .NET framework or anything. And that's a big advantage. When you talk about CI/CD pipelines, you see VSTS or Jenkins, we have what they call VSTS agent. When you do that Maven, clean store or like for Java or something, you run that inside the agent. Then what Microsoft does, Microsoft keep updating, have this agent with all the dependencies that you need. But some customers, what happened? They're still doing Java 6. And there's no Java 6 there inside the agent. What they do, they have to create a private agent for VSTS running on VMs. You can, by the way, you can run VSTS agents in containers, inside containers. I did that for a customer, it works fine. There are some limitations with license, you have to make sure that you just install the things that you need to build. And there are a lot of base images that you have. You don't have to do anything. The only thing you have to say, I want this container image to build my application. What's the nice thing? The nice thing is you can have as many as agents you want. Because there is no agent. There is just every time that you run a container, your dependence of your build process will be inside that container. Then it's a different thing. I think VSTS can run containers already. There is a Docker inside VSTS that can run. And that's it. Then you don't have to care about the agent with the version of the Java that's running inside the agent or no. You put that inside your container that's building the application. And that's what that step here, build the application. And you say, maybe it's easier to show here, but the build one, that's the image. Yeah, these 3 steps for the image, I call SQL Server front end and the API, like 3 containers. Each one has your dependence. And that's how it works with container Docker image. You have this base image like Microsoft Nano7, and you put your dependence on top of this. Let's say your front end layer was more than one layer there. And the same for the for the back end API. And that's just simple as that. Maybe it doesn't really make sense, but you have to understand that image just layers. File system layer. Every time that you install now, like Windows are a bit more complex than Linux, because Linux is like install something, it's just a file system. If you copy from here, and you'll be there. There's no registry or anything. Microsoft had to implement that for registry as well. And when you install something inside a container, they keep track of the registry changes as well. And that's part of the layer. Okay, that's something Microsoft has to do because the registry that the Windows operating system has. And yeah, once you get these dependencies and you pack that in one file, that's your image, you have to save this somewhere. I have this template now, like a VM template, let's say. I want to save that somewhere. The big difference here is, with VM template was 30 gig. The template could be 100 gig. Okay, a Docker image for Linux sometimes is just like a few megabytes. And they did a very clever thing, because you can track all the changes by the file system. It's like, you copy a file, then you copy another file, they keep track of all the files that change. It's like a file system, intersection of files. Each layer, you're going to overriding on this way. When the container runs, they cannot change these layers. They have like a write layer that they can write something when the container is running, like a temporary disk, but that's it. Okay, that's how container really works. And in Docker world, you have to save your image on this Docker registry. Microsoft provides what they call Azure registry, and then you can do a Docker command called Docker push. You do a Docker login, then you log in on the registry. You don't have to have any Microsoft command. You can use Azure CLI to do that as well, but you just do like a Docker push, and you push your file, your image, to that repository, like a GitHub. Okay. There's a public one for Docker called Docker Hub. Who has Docker Hub account here? Really? It's like GitHub, guys. Remember when you said, I have to create my GitHub now because everyone has a GitHub account? That's the time to create the Docker Hub account. Not joking. That's the time. It wasn't, not today, it was like 3 years ago, but I tell you, that's your time. Go create just now Docker Hub and create your GitHub, Docker Hub account. Okay, that you need that. You really need that if you want to play with container. Okay, 5 only. Push a little bit. Otherwise, you don't show the data. Yeah. Let's. Okay, just show you need these tools. Okay. You can see normally the tools that I need. That's including I think the Docker Hub account, and let me go here. See if it's still running. Probably not. What I did, I created that Docker Kubernetes cluster on Azure. I'm going to connect using Azure CLI. For kind of security reason, you don't expose your cluster, front end to the public. And if you want to connect there, you have to do a connection using Azure CLI and do like a port forward and run things in your local host. But that's command that you need. Otherwise, you don't have access to this dashboard. And you see dashboard be running on your local host. That's just a forwarding from the Azure, from the cluster that's running on the cloud. It's forwarding here from my computer using Azure CLI. What I did for the open service broker is I run some commands and show here. Probably easy to show you. At the end of the day, the only thing I need to create like a WordPress from my cluster is this thing here. It's a Helm install. Okay, that's a template of that installation, like a deployment template we call Helm chart that Microsoft provides. If you go, there is a link at the end. You go, Azure charts, and they can install WordPress with this command here. After you create the broker itself. Once you have the broker API set on your cluster, there are all the instructions on the cloud. Once you tell the cluster how to talk with Azure using the Open Service Broker API, you have a direct connection from your cluster to the Azure service using this Open Service Broker API. That's running in your cluster. And after that, with this Helm charts that they're going to provide, you can write yourself as well. If you have the knowledge to do it, you can just say install WordPress in your cluster. Okay, it's not on Azure. Could be on Azure because AKS. Okay, it's on Kubernetes, but the database of this cluster will be the Azure MySQL. How they know that? Because that's inside the template that they wrote. They wrote the template that using Open Service Broker API to go there. If I scroll back a little bit here. Let's see. I installed the catalog. That's the Azure catalog on my cluster. Now I can talk with the cluster. See, I have the catalog controller installed on my cluster. Then I said, okay, tell me all the service that you have on the cluster. And you see the command here. Get brokers, then get class. Redis Cache, SQL Server, Postgre, Storage, MySQL, ACI, Service Bus, Event Hub. All these things here, you can install Key Vault. You can create on Azure. And there is kind of integration like, Key Vault, they're going to give the secret. They're going to give the secret back. And you're going to create one secret inside Kubernetes without exposing the secret by mail or anything. And that list is growing every single day. If someone on Microsoft, some teams, and people, community help as well is open source. And one can help. If you want to create for API management, we can create with it. That's how it works. Then once you have this service, you just go start doing the create the instance that we discussed before and binding with your service. That's it. That's exactly what I did. And not sure if it's still running, but you're going to see that there is, inside my cluster, there is a WordPress application running. Let's see if it's really running. I think I deleted, but let's run it. I think I deleted the application for us to do again. Let's do again. I'll just delete before the one that I had created, but let's see. He asked me to delete origin. That's how I do it. That's my deployment unit now is Helm. I say I want to delete that. That's it. They're going to get my templates and delete everything that I installed. There are some rules like a persistent volume. If I don't want to delete, I can put like a retain, policy on my volume. Because I don't want to delete the disk of the MySQL or the server that something that's running on that's stateful running on my cluster. But that's delete. What's the name? Yes. And by the way, Helm is an open source. That's Microsoft now. It's done by Microsoft because of the company Microsoft acquired. It's all, done by Microsoft. And you can just delete and install again. Hold on there. Still not doing. Just create another one with another name. And that's it. If I go back to my cluster, not sure if there is a fresh. Yep. So there is a deployment happening now, WordPress 1. That's the second WordPress I'm creating. And they're going to ask, that's the normal Kubernetes, okay? That's not the open source broke API. But if I go on my Azure subscription and I look resource, I should see the found that. This one? Failed. Now because I was waiting for the disks. Because Kubernetes wait normally for you to attach the disks on the containers. There's a lot of things happening there. Yeah, you should see the a WordPress coming once you have the other things installed. And fail. That's the old one, I think maybe. Yeah, it's happening now. So they're creating disks for my application, like 10 gig. That's all on Azure. Okay, that's not the open broke API, but that's how Kubernetes work with Azure, with storage, with load balancers. If you go back here, you should be able to see the load balance. Yep. They still waiting for the, but it will be, see that's Nginx here, that's running on my cluster as well. So that's the IP. That's another thing running on my cluster at the moment. Then, but it's pretty much that. I don't think I have time to show the container environment thing, unless you want to give me 5 minutes.
So what we might do is we've got some time after the next presentation. So if you want to come back.
Maybe show that as a separate thing because something, I just got access this morning to show that.
Yeah, so
And, wasn't part of my.
Time in there.
then we can maybe show you later. It's a very nice thing. Is how to do microservice with Kubernetes with Visual Studio, without having to have local classes or anything, without have to redeploy all the time to let someone to look your code. We all can debug code of each other using this. I think you watched this session there about this as well. Yep. Okay, I think that's the main I want to show, and if you ask something. Thank you, guys.